All right, here we are with part 2. Okay, so then what if you are not disjoint, meaning that you're joined? So this is the general addition rule for two events, and this is for any two events. This one is on the formula sheet, and I'll show it to you in just a second. So it says if A and B are any two events resulting from some chance process, then the probability of A or B is equal to the probability of A plus the probability of B. So far it's the same. But if the events are joined, then I have to subtract out anything that overlaps. And so we say minus the probability of A and B. So on the formula sheet, how you're going to see this is with set notation or logic notation. So this is going to be the probability of A union B. So this U thing means union. This is going to be PA plus PB minus P of A and B. So this symbol here means intersection. All right, so this formula right here, this in this format is on your formula sheet. Formula sheet. Let's find it. So on your formula sheet, it's the very first one that you see here, exactly in this format. So you have to know that this means union, union means or, and this means intersection, intersection means and. So what does that look like? Well, okay, if I have two events that are joined, these are joined situations, the intersection, the probability of A and B is right here. So let's say this is event A, here's event B, they overlap, this is the place where they intersect. So any values or any elements that are inside there are things that they have in common. So when I do A or B, I take everything in A, everything in B, but then I want to subtract out any numbers or any events that are being counted twice. So the union means, here's a union, here's a picture of what that looks like. The probability of A union B means I'm taking everything in A, everything in B, but I'm not counting their intersection twice. This is the union in terms of a picture. So let's take a look at a couple of examples, how we use these formulas. And just I want to remind you that this formula here is for joined events. Remember, if they're disjoint, the probability of A and B is equal to 0. Okay, so if they're disjoint, then this thing is 0. And so that means that A union B is just A plus B. We talked about that on the previous page, right? The addition rule for mutually exclusive events. So here A or B means A plus B, but that's because A and B is 0. All right, so here's an example. Who owns a home? So we have some information about educational achievement and home ownership. A random sample was taken from the 2000 census. Okay, so what we want to do is create a two-way table that displays all of this data. So we've got two major categorical variables here. So we really have home ownership as the main categorical variable here. And either they own a home or they do not own a home. And then over on this side, we have their educational achievement. So they either went to high school or they did not. So we can make this two-way table. We can put in our values here. It tells us that, let's see, overall 340 were homeowners. So I'm going to put down here a total. Here's 340. And 310 were high school graduates. So overall, 310 were high school graduates. So we've got totals here as well. Let's see, 221 were both homeowners and high school graduates. So that's going to go here. And so then from here, we can fill in the rest of the table through some subtraction. Here's 89. This is 119. It told us in total that we had 500 people who participated in the survey. That means that we've got 160 here, 71, and 190. Okay, so here's the two-way table that displays this data. The real meat of the table is this part right there. Okay, so it says, suppose we choose a member of the sample at random. What I'm going to do is I'm going to label these two events. So we've got home ownership. Either they own a home, I'm going to call that event A, or they do not own a home. I'm going to call that a complement. They're in or they went to high school, I'll call that event B, or not, so B not. These two things are joined events. So you could think about it this way. Here's A, here's B. Inside this little space is A and B. And then outside of the bubbles are anything that's not A and anything that's not B. So, suppose we choose a member of the sample at random, find the probability that the member is a high school graduate. So in this case, the probability of B. So it's not asking me about home ownership. I'm just looking at high school graduate. So there are 310 out of 500, which is 31 out of 50. You can turn it into a percent or a decimal if you prefer. This is just fine as well. Is a high school graduate and owns a home. So the probability of being a high school graduate and owns a home. So these are overlapping events. In the table, it makes it really easy to just see where that is. A and B is inside this box. So 221 out of 500. And then the last one is a high school graduate or owns a home. So is a high school graduate or owns a home. Okay, so this is our general addition rule for our two events. So when I see this one, I automatically like to write the formula. It's good practice. So we're going to write P of B plus P of A minus P of A and B. Because they overlap, we've got this part that's overlapping. I don't want to just add A and add B and then not take care of that double counting. So the probability of B was 30, well, I'm going to write 310 over 500 because we're going to get common denominator here. Probability of owning a home, so owning a home is 340 over 500. And so you can see right here that we've double counted 221. We have 221 in the 310, we have 221 in the 340. And so we want to subtract out that 221 out of 500. And so we get 429 out of 500. Now you could also do this an alternate way with a complement if you'd like. Since we want A and B, A or B, so think about this picture for a minute. If I want A or B, that's all of this business, all of this stuff inside the two circles. An alternate way would be to think of it as 1 minus the complements of both. You could do it 1 minus the probability of A complement and B complement. So 1 minus, this means does not own a home and does not go to high school. There are 71 out of 500, and that turns into 429 out of 500. All right, we'll do one more example together. Let me just double check and make sure. Yep. One more example together. And then next time we're going to do things a little bit more complicated. We're going to do the conditional probabilities. Like if you know someone who owns a home, what's the probability that they went to high school? We're going to work backwards using some conditionals next time. So for today, we're just going to be really, really straightforward and just deal with this addition formula. So phone usage. You're given some information about the households and what kind of phones they have. So you've got landline or not, and then you've got people that have a cell phone or not. So this is back in 2012. So some people still have both. I think that those percentages that have both are pretty small now. But anyway, it says 60% of households had a traditional landline. So this is different because we're looking at percentages as opposed to counts, and that's okay. 89% had cell phones. 51% had both. And so then we're going to randomly select a household. We can fill in the rest of the table just through subtraction. So this is 0.09. This is 1. So this is going to be 0.4, 0.02, and 0.11. Okay, so here's our two-way table, and then it also in part B asks us to make a Venn diagram. So I kind of, sort of alluded to the fact that you can take a two-way table and you can put it into a Venn diagram, but we didn't do it here. Let's do it for this problem. So you've got joined events. Let's let L be the landline and C be the cell phone. Here's L, here's C. So we've got 51% that has both. And I have 2% that have neither. Here's the biggest place where students make mistakes. So the landline bubble is 60%. 51% is inside here, and so that means that there's 0.09 or 9% on this side. So this is one of the biggest mistakes, is that students will want to put 0.6 right here, but 0.6 is the whole circle added together. And so then the same thing for the cell phones. So the whole bubble together is 89, and so then this piece is 38, because the whole bubble together, 0.51 and 0.38, is 89. So here is your Venn diagram. So this is part A, here's part B. Now it says in part C, find the probability that the household has at least one of these two phones. So they have a landline or they have a cell phone. Okay, so the probability of L plus the probability of C minus the probability of L and C. So the probability of L is 0.6, the probability of C is 0.89 minus 0.51, and you get 0.98. So I want to point out to you that these values I got right from the table. Landline is 0.6, cell phone is 0.89, minusing out the 0.51. It's actually easier, in my opinion, to get this probability just from the diagram. From the diagram, remember that the OR means these three things. So P of L or C is 0.09 plus 0.51 plus 0.38. You can just add this plus this plus this, and that way you're not double counting that 0.51. You end up with the same answer. So however you like to do it. You could do it from the diagram, the Venn diagram like this, or you can do it using the formula and the table. Part D, find the probability that the household has neither type of phone. So neither type of phone is right here or right here. So notation-wise, I would say not a cell phone and not a landline. 0.02. And finally, part E, find the probability that the household has a cell phone only. So that means the probability they have a cell phone and not a landline, 0.38. Okay, I will see you next time.